So the previous CGE was very simple, so we are going to introduce some complexity in this very simple CGE in order to get a more realistic CGE, and we are going to do it very progressively. So the first assumption that we change is the assumptions concerning only one good. Now we have three goods. We have three goods, and these goods are agriculture, industry, and services. So we can talk about sectors instead of goods. That doesn't change, and so we can have any number of goods. So it can be n goods. It's not going to change anything. The principle is to change from one good to more than one good. And so it's going to change two things. First, the modeling of supply. So we have three production functions instead of a single one. But we have also the fact that each good is used as an intermediate consumptions in the production of all other goods and of itself also. And so we have also a change concerning demand, because we have utility depending on the consumptions of three goods. And so we have a change, modifications in the modeling of the demand block. So let's start with a key economic question. What is production? Production is the process of buying and assembling inputs in order to obtain an output. We suppose that here that each producer produces only one good. So inputs are primary factors like capital, labor, land, and intermediate goods, which are entirely consumed during a production period and integrated in the final output. So production combines value added, that is to say capital and labor, and intermediate consumption. So CGE modelers are used to represent production with tree. The top summit of this tree being the level of produced output, and this volume of output is obtained from value added, that is to say primary factors, and also intermediate consumption. Value added is obtained from the combinations of here labor and capital, while total intermediate consumption is the additions of intermediate consumption of each good by the good here represented, good I. So we have the intermediate consumptions of agricultural good for the productions of good I, of the industrial good by good I, and of services by good I. We also need to make assumptions about the substitutability or the complementarity between these inputs. I assume here that there is a Leontief technical relation at the first level of the tree. So there is proportional relation in volume terms between the level of output and the value added in volume, and also between this level of output and the total intermediate consumption. Concerning total consumption, intermediate consumption, there is also a Leontief relation between total intermediate consumption and the intermediate consumption of a specific good by sector. So when productions of good I is increased in volume, the intermediate consumption of each good by sector I is in volume increased proportionally. On the value added side, I make a different assumption here. There is a Cobb-Douglas technical relation between total value added and the primary factors, here capital and labor. So a Cobb-Douglas technical relation means that the share in value of each primary factor in total value added is constant. So we have here a simple representation of the production process with three goods. Of course, it is more or less realistic, but CGE modelers can adopt different assumptions in different sectors. They can introduce constant or variable substitutability. They can model the substitutability or complementarity of a primary factor with an intermediate good, for example, capital and energy, or land and fertilizer. So many different assumptions may be considered. So how do we translate all these assumptions into equation? Let's start with the summit of the production tree, which is a Leontief relation between output and either value added or intermediate consumption. So this is the production block, and we are going to model the first level of the production tree, which is a Leontief. And so this Leontief relation will be translated into three equations. First, a proportional relation between value added VA in sector I and output level Y in sector I. And so the coefficient is called psi underscore VA. And a second relation, which is also a proportional relations between total intermediate consumption in sector I, which is called IC in sector I, and the level of output in volume in sector I, which is called Y in sector I. And the coefficient between intermediate consumption and output is called psi underscore IC. And the third relation is very simple because it's in value the fact that the total value added in value, PVA in sector I multiplied by VA in sector I, plus the total intermediate consumption in value, PIC in sector I multiplied by IC in sector I, is equal to the total value of the production, which is here PI, the price of the output, multiplied by the level of output in volume, YI. Let's notice that we have created, in fact, a new variable, which is the value added in volume, which is called VA in sector I, the total intermediate consumption in volume, which is called here IC in sector I. And so we have to make a distinction between the value added in value and the value added in volume, and also the total intermediate consumption in value and the total intermediate consumption in volume. Now let's work with the value added branch of the tree. This branch gives birth to two branches, labor and capital, and so there is a Cobb-Douglas relation. This is the value added. So this is second part of the production block, which is the Cobb-Douglas at the second level. And so we have again three relations. First, we have the definitions of a Cobb-Douglas. So value added is a Cobb-Douglas of capital and labor. So we have VA in sector I, which is equal to A in sector I, which is a parameter, a scale parameter, multiplied by demand for capital, KD in sector I, to the power alpha in sector I, multiplied by LD, which is the demand for labor in sector I, to the power 1 minus alpha in sector I. So we have a Cobb-Douglas relation between demand for capital and demand for labor on one side and value added on the other side. And so you know that if we minimize the cost of these primary factors in order to get a certain level of value added, we obtain two relations which express the fact that the share of each primary factor in value in the total value added is constant. So we have W multiplied by LD in sector I, which is in fact the value cost of labor, which is equal to 1 minus alpha multiplied by the value added in value, which is PVA multiplied by VA, and another relation concerning capital, which is R multiplied by KD, is equal to alpha in sector I multiplied by the value added in value, which is PVA multiplied by VA. You understand that the W and R, there is only one W and one R in the economy, because in fact so we have perfect mobility of labor and capital between sectors, and so there is only one remuneration of labor and one remuneration of capital, and we have a composite price of value added, which is PVA. We do not have to express an equations in order to find out what is PVA. It could be PVA multiplied by VA is equal to WLD plus RKD, but in fact it is implicit here, because in fact the coefficients of the last two equations are 1 minus alpha, and so if we add up these two equations, we get PVA VA is equal to WLD plus RKD. So let's complete the production tree and its modeling by considering the case of intermediate consumption, which gives birth to three branches: consumption of agricultural good by sector I, of industrial good by sector I, and of services by sector I. So this is total intermediate consumption. And so we have again a Leontief, which is the second level of Leontief. And so we have two relations which are quite identical to the Leontief first level. So it means that we have first proportional relation in volume between total consumption, intermediate consumption, IC in sector J, and consumption of good I in sector J, which is called CIJ, of I and J, because it's a double dimension variable. And so the other relations is only the total intermediate consumptions in value, which is PIC IC, is equal to the sum of the intermediate consumption of good I in sector J in value. So it is price of good I multiplied by intermediate consumption of good I in sector J, which is called CIJ. Of course, we have to take care to the number of variables and the number of equations in this production block, because we have to be sure that we have enough information to find out a solution. That is to say, we must have an identical number of free variables and independent equations. So in fact, we have 8 generic equations in this block. What do I call generic equations? It's an equations defined on a set or two sets. So I count as just one equation, one generic equation, such an equation, if I take into account the number of sectors. So with 8 generic equations, we have 30 equations. So in fact, these 8 generic equations, we have 7 one-dimensional equations and 1 two-dimensional equation. You can have a look at the previous slides, and this is the number of generic equations and the number of equations. And so with this 8 generic equation, I have in fact 8 generic variables. Y, the output in sector I, VA, the value added in sector I, IC, the total intermediate consumption in sector I, CIG, JI, which is the intermediate consumption of a good J in sector I, the demand for capital KD, the demand for labor LD, the price of the value added the composite price of value added, which is PVA in sector I, and the composite price of intermediate consumptions, which is PIC in sector I. So with these 8 generic variables and with 3 sectors, we have 33 variables. So we have the same number of independent equations and free variables. You may think that there is also the price of the output, PI, the remunerations of capital, R, and the price of labor, W, but in fact they are determined not in this block, they are determined in the block which is dedicated to market equilibrium, so we do not have here to include these variables. Let's consider right now the modeling of consumptions, and so we can represent consumption also by a consumption tree. Here it's very simple because in fact we have a simple assumption, which is that utility is Cobb-Douglas. So it means that the share of each good in total consumption in value is constant. The representation by the tree is also very simple because utility drawn from the consumptions of the 3 goods is depending on first the volume of consumptions of the agricultural good, the volume of consumptions of the industrial goods, and the volume of consumptions of services. And so this is a Cobb-Douglas which is really simple and easy to model. So how do we model this consumption block? Again, it's very simple with the Cobb-Douglas assumption, because in fact the block modeling final consumption here is represented by only 2 equations. The first equations, which determines the level of utility attained by the households. So it's U, which is equal to the product of the consumption of each good in volume to the power parameter, which is here gamma. And a second equation, which is in value, the consumption of one good is a constant part, a constant share of the income in value, INC. So with these 2 equations, I have modeled completely the consumption block. So here is our second general equilibrium model, which is a little bit more complicated and more realistic than the previous one, because here we have 3 goods instead of 1, and we have intermediate consumption. So the model consists in 6 blocks of equation. The first 3 blocks are production block. So the first one is about the Leontief at the first level of the production tree. The second block is about the Cobb-Douglas at the second level of the production tree. The third block is on the Leontief at the second level of the production tree. Then on the right, we've got an income block consisting in only 1 equation, equation 9. Then we have the demand block with 2 equations, 2 generic equations, equation 10 and 11. The first one being the level of utility, the second one being the consumption of each good, final consumption of each good. Then we have the last block, which is the equilibrium on each market. And so we have equation 12 with the equilibrium on the good market, then labor market, then the capital market. Let's notice that we have 1 restriction for the same reason as for the previous CGE model. So we have one restriction. We fix one numeraire, which is here the labor remuneration. W is equal to 1. And we add one variable, one free variable, which is called Léon. So we've got 14 generic equations, but if we take into account that there are 3 sectors, we have 40 equations. Because in fact we have, with the first block of production, 3 plus 3 plus 3 equations, so 9 equations. The second block consists in 3 plus 3 plus 3 equations, so it is again 9 equations. And the third block is 9 plus 3 equations, that is to say 12 equations. So we've got, for the production block, the 3 production blocks, we have 30 equations, 9 plus 9 plus 12. Then the income block consists in a single equation, equation 9. Then we have the demand block with 2 generic equations, but it consists in 4 equations, 1 for the equation 10 and 3 for equation 11. And then we have the equilibrium block with 5 equations, 3 for the goods market and 2 for the primary factor markets. And we have in fact 14 generic variables: VA, Y, IC, P, PVA, PIC, KD, LD, R, CIJ, INC, the income, U, the utility, C, consumption of each good, and Léon, which is the Walras variable. So we have 14 generic variables. If we take into account the number of sectors, we have 40 free variables and 40 independent equations. So we have the same number for free variables and independent equations, so we can determine and find out a solution to this model. So a few remarks about this second CGE model. First remark, the capital supply and the labor supply are still exogenous variables, so they are not explained by the model. Second remark, so alpha, gamma, psi underscore VA, psi underscore IC, psi underscore I, J, C, and A are parameters of the model, so they are going to be calibrated when we will have introduced macroeconomic data. Third remark, again we add a new variable, Léon, and we keep one price constant, here the price of labor. So with that we have the same number of independent equations as the number of free variables, and we keep all equations. Fourth remark, there is a single price for labor and capital, so it means that there is perfect mobility of factors across sector by assumption. Okay, we can have a different assumption. And final remark, other assumptions are possible. So for example, we could have an imperfect mobility of productive factors across sector, or even a total immobility of factors in each sector. We can have other functional forms. For example, we can introduce some substitutability in the demand function or the production tree.